Today, we're going to be learning how unequal heating causes wind. In previous lessons, you learned that the uneven heating of Earth's surface by the sun causes some areas to be warmer than the others. This uneven heating of land forms wind systems. Wind is caused by differences in air pressure. Areas of high pressure move to areas of low pressure. Air pressure is related to density, so let's review density. Which one has the greater density, the greater pressure? Well, look at how the particles are spaced. On the left, the particles are spaced very close together. On the right, the particles are spread apart. So on the left has a greater density and a greater pressure. The right has a low density and lower pressure. Notice the temperature is inversely proportional to both pressure and density. This means that as temperature decreases, both pressure and density increase, and that as temperature increases, both pressure and density decrease. The particles are more crowded in the lower temperature, colder area to the right, and want to spread out. Think of this way. Matter naturally wants to move from where it is crowded to where it is less crowded, just like us, a crowded room. This concept is true in all of science. So particles will want to move from the right, which has a lower temperature, higher density, to the left, which has a higher temperature and lower density. Why? Because it's less crowded. In the tropics near the equator, warm air rises. When it gets to about 10 to 15 kilometers, 6 to 9 miles above the Earth, it starts to flow away from the equator and moves towards the poles. Air that rose just north of the equator flows north. Air that rose just south of the equator flows south. When the air cools, it drops back to the ground, flows back towards the equator, and warms again. The now warmed air rises again, and the pattern repeats. This pattern is known as convection, and it happens on a global scale. It also happens on a small scale within individual storms. Warm air rises, resulting in lower pressure. On the other hand, cold air will sink, making the air pressure higher. This is where the terms low pressure and high pressure come from. Differences in density and pressure cause wind and air movement. The movement of the air occurs in the convection currents. Convection currents are simply the transfer of heat by the circulation or the movement of the heated parts of a liquid or a gas. We'll start at the Earth's equator, where solar radiation is high year-round. Air near the equator is warmed and rises because it's less dense than the air around it. The air near the equator is heated and rises and is indicated by the red arrows. The rising air creates a circulation cell called a Hadley cell, in which the air rises and cools at high altitudes, moves outward towards the poles, and eventually descends back to the surface. The continual heating and rise of air at the equator creates a low pressure there, which causes air to move, wind, towards the equator. That takes place where the air rises. On the other hand, sinking air creates high pressure at the surface where it descends. A gradient of pressure, low to high, is formed and causes air to flow away from the high and towards the low pressure at the surface. Hadley cells, shown in the red circles, are formed as the air rises. The Earth would simply have two large Hadley cells if it didn't rotate, but it does rotate. The rotation of the Earth leads to the Coriolis effect. Without going into detail as to why the rotation creates this apparent force, the Coriolis effect causes winds and all moving objects to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. The Coriolis effect causes winds to deflect as they travel within circulation cells and results in the two very large hypothetical Hadley cells breaking down into 6 smaller cells, which looks something like in the diagram. The rotation of the Earth is responsible for the Coriolis effect, which breaks the two large stop. The Coriolis effect causes winds to deflect as they travel within circulation cells and results in the two large hypothetical Hadley cells breaking into 6 smaller cells, which looks something like in the diagram. So we have major wind systems and wind belts that we're going to be talking about. There are 4 wind systems. You're responsible for knowing where they are and which way they blow. And there are 3 types of wind belts. Polar easterlies, indicated by the green arrows, can be found at the north and south poles, and they are cold and dry because of where they're located, which is at high latitudes. This type of wind system forms when cold air at the poles transfers towards the equators. Polar easterlies are located 60 and 90 degrees latitude in both the southern and northern hemisphere. Tropical easterlies, as shown by the green arrows, take direction in an east to west flow because of the rotation of the Earth. As air from the equator rises, it gets warmer, and when it cools down, it comes back down to the equator. Tropical easterlies are located 0 degrees to 30 degrees latitude in both hemispheres. These are also called trade winds. Trade winds blow from the horse latitudes to the low pressure of the ITCZ. Trade winds get its name from the capability of blowing trade ships across the ocean very quickly. In the northern hemisphere, the winds blow from the northeast, which is called the northeast trade winds. In the southern hemisphere, the trade winds blow from the southeast, and surprisingly, they're called the southeast trade winds. Prevailing westerlies, shown with the green arrows, are the winds in the middle latitudes between 35 and 65 degrees latitude. This is where we live. They tend to blow from high pressure area in the horse latitudes towards the poles. These prevailing winds blow from the west to the east, steering extratropical cyclones in this general manner. The Intertropical Convergence Zone, the ITZZ, shown by the arrow, is also known as the Equatorial Convergence Zone, or the Intertropical Front. It forms when southeast and northeast trade winds converge in a low-pressure zone near the equator. It usually appears as a band of clouds and comes with thunderstorms, which are short but produce large amounts of wind and rain. Doldrums is the same thing as the IT's stop. Intertropical Convergence Zone, shown by the green arrow, is also known as the Equatorial Convergence Zone, or the Intertropical Front. It forms when southeast and northeast trade winds converge in a low-pressure zone near the equator. It usually appears as a band of clouds and comes with thunderstorms, which are short but produce extreme amounts of rain. The doldrums is the same thing as the ITCZ. There's just a different name for it. This name originated from some sailors who noticed the stillness in the rising air and called it the doldrums, which means depression or despondency. Horse latitudes, shown by the green arrows, are also known as a subtropical high. They are about 30 to 35 degrees north and south of the equator. Horse latitudes is a region where there are weak winds because of high pressure and decreasing dry air. The origin of the name horse latitudes is uncertain, but it is said that ships that needed wind power couldn't move on water, and the sailors threw horses and cattle overboard to save the ship. So global wind systems, they determine the weather patterns for the entire climate. Smaller wind patterns are called local winds, and they are more localized, like just Virginia Beach, where global wind patterns are all over the world. That was terrible.